Hello student, welcome back to my channel Kunal Sir at JEE NEET Chemist World. Like previous few classes, today also I am going to discuss very important topic for upcoming JEE Advanced exam, which is nothing but a titration based problem. So now in titrations, first when I will discuss this problem, before that I will explain titration and regarding indicator phenolphthalein and methyl orange, few points I will discuss, then I will come to the problem discussions. First you look at the problem what they are giving. Here they are telling a mixture of NaOH and Na2CO3, that means sodium hydroxide and sodium carbonate required 25 ml of 0.1 molar HCl using phenolphthalein as the indicator. However, the same amount of mixture required 30 ml of 0.1 molar HCl when methyl orange was used as the indicator, and the molar ratio, that means the mole ratio of NaOH and Na2CO3 in the mixture was how much? That is the questions. Now first we need to know what is called as a titration. If you look at very quickly, what is the meaning of a titrations? Titration is nothing but a titration. It is a determination of unknown solution, determination of unknown solution concentrations by the help of standard solution. So in standard solution strength also we will know, standard solution volume also we will know, and then by that way, that means by standard solution measured volume and known concentration will be utilized to measure the concentration of an unknown solution. It's a volumetric process. It is called as a titration. So if you quickly look at the setup of titration, there will be one burette like this. My drawing is not good, just this will be burette. Here one knob will be there, and here one solutions will be there, and here their measurement will be there. And now in below there will be conical flux, or you can take a beaker. This is a conical flux. Here another solutions will be there, and through these knob, drop by drop you can put over here, and in these solutions there will be indicator also will be there with this solution. And generally here we will take a standard solution, and in that standard solution indicator plus standard solutions will be over here. Now suppose standard solution, I am taking 25 ml and I am taking the concentration is 0.1 molar, and now this is I am telling the solution A, and concentration of this solution I need to find out. Suppose this indicator, what it will indicate? It will indicate the end point of the reaction. That means whatever the standard solutions will be there, it will fully consumed by the solution A. So now from this burette, this is your burette, and this is your conical flux, and now by this knob, drop by drop I will put the solution A into the standard solution, and slowly the reaction will start and reaction will proceed. And now, and in the end point, indicator will change its color and will show there is all standard solution is consumed by the solution A. Now suppose when the end point reached, I measure the volume from burette, I observe it is 17.8 ml. From here I observe that much consumed to reach the end point. And now that means this 17.8 ml is a volume of solution A which is fully reacted with the standard solution. Standard solution was taken 25 ml, concentrations of standard solution was 0.1 molar. By applying the equivalent concept, we can write down at endpoint, or also it is called as a equivalence point, or also it is called as a equivalence point, or also it is called as a equivalence point. So at endpoint or equivalent point, we can write down as per the law of equivalence of solution A will be equals to the equivalence of standard solutions. As per the law of equivalence, we can write down equivalence of solution A will be equals to equivalence of standard solution. Then equivalence will be equals to number of moles into n factor. So equivalence we can change it number of moles of A into n factor, and here also number of moles of standard solution into n factor of standard solution. Suppose I am assuming both the solution n factor is 1. So then immediately this n factor 1 and this n factor 1. Suppose I am assuming. And particular reaction we will come to know the n factor. Like for the different types of acid, I explain how to calculate n factor. Different types of base, I explain how to calculate n factor. For redox reaction in a particular medium, how to calculate n factor. Already it is there in my video, my dear. If you have a doubt, you can have a look over there. So now n factor here just I assume for standard solution as well as solution A is nothing but a 1. So then number of moles into n factor is the equivalence. So then number of moles I can change molarity of the solution into volume of the solution in liter is a number of moles. For that purpose, suppose I am telling concentration of A, I don't know. What we don't know in algebra, we used to take let x, let y, like that. I am telling here the concentration of A is x molar. I will find out the value of x. So then immediately molarity into volume of the solution in liter is a number of moles. So now if you look at molarity, I took it for A is x molar. I will find out the value of x into volume of the solution in liter 17.8 ml means 17.8 by 1000 ml. If you divide it by 1000, you will get the volume in liter, and then n factor is 1 equals to, here also same logic, volume of the solution in liter into molarity for standard solution is a number of moles. So that's why volume of the solution in liter into molarity is 0.1, volume of the solution 25 ml, that's why 25 by 1000 into n factor, here also 1. You look at from this equation, I can easily calculate the value of x. One equation, one unknown, I will get the value of x, which is nothing but a molarity of solution A, which is nothing but a concentration of A. This is your titration. Now regarding phenolphthalein and methyl orange, few points I want to discuss, then we will come to the problem. Phenolphthalein is a weak acid, this indicator, and phenolphthalein I am short denotions. This is a short expressions, short presentation, better say short presentations of phenolphthalein. This is a short presentation of phenolphthalein. Now if you look at this, phenolphthalein will be dissociated like this. It's a weak acid and H plus. That means phenolphthalein is a weak acid, it can provide the H plus. Now without the H plus form of phenolphthalein, this is a colorful and this color is a pink, and with protonated form is a colorless phenolphthalein, and which is colorless, and this is a colorful. Now if you look at, if medium is basic, then what will happen? Then OH minus will be there more. That OH minus will react with H plus and it will form a what? H2O. Now that's why these H plus concentrations will be what? Decreases. Then reaction will go to the which direction? Forward direction. So whenever medium is basic, OH minus will react with H plus, water will form and H plus concentration decreases, reactions will proceed in a forward direction. That means protonated form of phenolphthalein will be converted to unprotonated form. That means protonless form, which is a pink color. That's why phenolphthalein used to give pink color in a basic medium. But if the medium is acidic, that's why this pink color will be observed in basic medium. But if medium is acidic, then what will happen? H plus concentrations will be increases. Reaction will be backward directions. Whenever reaction will be backward direction, colorless form will be dominant. Colorless form will be increases. That's why then solution will be colorless. That's why whenever the acidic medium phenolphthalein will be colorless, basic medium phenolphthalein will show the pink color. Whereas methyl orange, if you look at, this is the short representation of methyl orange. Methyl orange is a weak base. So whenever OH attach, then it's a yellow color. So without OH, methyl orange will be a red color. Without OH, methyl orange is a red color, methyl orange indicator. Now, if my OH concentration increases, that means medium is basic, then what will happen? Reaction will come in a backward direction. Why? Because due to the common ion effect, dissociation of MeOH or methyl orange will be less. So then that means reaction will be basically which direction it will come? It will come in a backward direction. That means this form will be dominant. That's why that time it will show the yellow color. If medium is acidic, OH concentrations will be decreases. So then reaction will go to the forward direction. Methyl orange will be only Me plus form. That's why in acidic medium it will show the red color. So red color where it will show? In acidic medium. Whereas basic medium, OH concentration will be more, reaction backward direction. So that's why it will show the yellow color. Anyhow, whatever the medium, acidic or basic, methyl orange can be utilized. But phenolphthalein, if medium is acidic, we can't utilize the phenolphthalein. Based on that, the problem was given, advanced problem. If you look at into the first slide, what they are giving into the first slide problem, then we will going to solve that problem in an elegant manner when you will be confident about this type of problem, not only this type of problem in titration. Now, if you look at here, mixture of NaOH and Na2CO3 required for 25 ml of 0.1 molar HCl using phenolphthalein as the indicator. So now whenever phenolphthalein is utilizing, then the NaOH react with HCl and it will form NaCl and water. That means based on the situation, phenolphthalein will show the color change. Suppose if you add the NaOH slowly into the HCl solution, when medium will be basic, then color will change to the acid to the basic going means colorless to the pink color. So we can get it this one. But whenever Na2CO3 will be there, Na2CO3 in a step by step manner reaction will occur. First it will react with the HCl and it will convert NaOH/CO3 plus NaCl. This reaction will be taking place. Now second stage, that means out of 2 sodium only one will be replaced by H plus. Now whenever these NaOH/CO3 will come with these HCl reaction, then reaction will form H2CO3 and with that NaCl, and this H2CO3 is a acid. So that's why that phenolphthalein, if you utilize the indicator, these reactions you cannot catch. Why? In acidic medium, phenolphthalein will not show the color change. So that's why what will happen over here, whenever you are utilizing the phenolphthalein, only reaction will, this one you can catch, this reaction, and this one you can catch. This is only for phenolphthalein when acting as an indicator. And whenever methyl orange you are acting, whatever may be the medium, you know very well, in acidic medium, phenolphthalein, methyl orange color will be nothing but I just show you. Acidic medium, what will happen? H plus react with OH minus. The reaction will be forward direction, red color. If basic medium is there, reaction will be backward direction, it will be yellow color. Whatever may be the medium, methyl orange can indicate the end point. So that's why whenever methyl orange will be there, then the total this reaction can be calculate, this reaction can be determined by methyl orange. So indicator, methyl orange indicator. So that's why whenever you have a phenolphthalein only NaOH reaction and Na2CO3 half reaction can be detected by phenolphthalein, because Na2CO3 full reaction means acid will be created. Acidic medium phenolphthalein cannot show the color change. That's why this last part of the reaction cannot be calculated by using phenolphthalein indicator. That is the basic idea of the problem. But methyl orange, no issue. So basic medium also it will work, acidic medium also it will work, because both medium it will show the different color. So that's why for phenolphthalein only this reaction and this reaction, but methyl orange means entire this three reaction will be occurred. So based on that, this problem, if you look at whenever your phenolphthalein using, that time 25 ml 0.1 molar HCl, whenever methyl orange using, that time 30 ml 0.1 molar HCl are required. Now if you look at how I will solve this problem, if you look at very nice way, I will solve this problem so that all types of this problem you can solve very quickly and you can get the success for the upcoming JEE advanced exam. Now here what I am doing over here, I am writing add endpoint or equivalence point for phenolphthalein. Suppose I am writing when I am utilizing that phenolphthalein indicator, then what is happening, my dear, that equivalence of HCl will be equals to equivalence of NaOH plus equivalence of Na2CO3, but by the mind you have to remember it is a half reaction, because it only will be converted up to NaHCO3. NaHCO3 further reaction with HCl, H2CO3, in that reaction we cannot utilize the phenolphthalein. So that's why this is the for phenolphthalein. Now you write down number of moles into N factor. Number of moles of HCl into N factor. N factor for HCl equals to 1, because it's a monoprotic acid. In my N factor calculation, I told number of ionizable H plus or replaceable H plus or basicity of the acid is a N factor. So then same way, here number of moles of NaOH into N factor of NaOH is 1 plus number of moles of Na2CO3 into N factor. Here N factor half reaction, that's why it will be how much? 1. Because Na2CO3 will be converted to NaOHCO3. Out of 2 sodium, only 1 will replace by H plus. That's why here N factor is 1. That's why I write down it's a which reaction? Half reaction. Now number of moles of HCl, for that data they provided molarity into volume of the solution in liter. So molarity 0.1, volume of the solution in liter 25 by 1000 into 1 equals to number of moles of NaOH plus number of moles of Na2CO3. Suppose this is my equation 1. Then for the methyl orange, what I can write down? For methyl orange I can write down like this way. So same equivalence of HCl will be equals to equivalence of NaOH plus equivalence of Na2CO3. And now instead of equivalence of HCl, we can easily write down that number of moles of HCl into N factor 1. Here number of moles of NaOH into N factor 1. Here number of moles of Na2CO3. Now N factor is 2. Why? Because both the reaction will occur. First Na2CO3 will be converted to NaHCO3, and then also NaHCO3 when it will be converted to H2CO3, that also can be detected by methyl orange. That's why here N factor is 2. So now if you look at here the number of moles of HCl data they provided 0.1 into 30 ml. That's why 30 by 1000 into 1 equals to number of moles of NaOH plus 2 into number of moles of Na2CO3. This is your equation 2. Now equation 2 minus 1 if you do, what you will get? Equation 2 minus equation 1 if you do, what you will get? You look at here, you will get point, here calculation if you do, here another decimal point, so then 0.0025. So these has to be subtracted from point here 00, point here if you look at here there will be 40, that's why 0.0030. so then immediately this has to be subtracted, so then immediately what I will get over here? 0.0005. so then these will be your answers you are getting this side, and this side if you look at NaOH and NaOH will be cancelled, and then 2 moles of Na2CO3 and 1 mole of Na2CO3, then number of moles of Na2CO3 will be equals to, number of moles of Na2CO3 will be equals to 0.0005. This is we are getting. This value if you put into the equation 1, then number of moles of NaOH will be equals to, so number of moles of NaOH will be equals to, you will get it, which is nothing but a, so 0.0005 that you have to be subtracted from 0.0025, so this has to be subtracted from 0.0005, where you will get 0.0020. You will get these things, 0.0020 you will get these things. This is nothing but a your number of moles of NaOH. And now the molar ratio of, they are asking number of moles of NaOH by number of moles of Na2CO3, that molar ratio they ask in that question. Then number of moles of NaOH 0.0020 by number of moles of Na2CO3 0.0005, which is nothing but a, here 10 power of 4, here 10 power of 4, 10 power of 4, 10 power of 4 cancel out, then 20 by 5, which is nothing but a, you are getting 4 by 1, which is nothing but a 4:1. So your answer is how much? 4:1. These will be the molar ratio. So now you look at the problem, how I explain this problem in a very easiest way. So that means equivalence of HCl will be equals to equivalence of NaOH plus equivalence of Na2CO3. For phenolphthalein only you have to remember half reaction, N factor is 1, and then equivalence equals to number of moles of N factor we change. We got one equation. For methyl orange same idea, equivalence of HCl will be equals to equivalence of NaOH plus equivalence of Na2CO3. But here only difference, for Na2CO3 it will be a full reaction, N factor will be 2. We got the 2 equation. For all number of moles data we change is in terms of a molarity into volume of the solution in liter, and then 2 equation we got, equation 2 minus equation 1 we did, then we got the number of moles of Na2CO3 equals to 0.0005, and putting that value into the equation 1 we got the number of moles of NaOH equals to 0.0020. so then both the number of moles we got, and then we took the ratio, then only we got the molar ratio, which is nothing but a 4:1. So I hope you understood my dear student. To get more and more this type of video, please come have a look my channel, comments, so that you can get the customized problem for upcoming JEE advanced. Thank you very much. Thank you all.